Warm wishes to everyone. Welcome to my video. My name is Dr. Ayan Devnath. I am an IIT Delhi alumni. I have total 8+ years of experience in the field of data science and AI. So coming back to the previous diagram which I have shown, that this is negative class, this is positive class. We know the equation of the hyperplane is y is equal to w transpose of x plus b. Here note that the intercept is not 0, so b is not 0. Okay, we generally write the equation of the hyperplane as w transpose of x plus b equals to 0. I have already explained this. Now, what will be the equation of these marginal planes? This will be w transpose of x plus b equals to plus 1, because it is passing through a point which belongs to positive class. And what will be the equation of this? W transpose of x plus b equals to minus 1, because this marginal plane is passing through a point which belongs to negative class. Now in hyperplane, this marginal distance should be maximum. This distance should be maximum. Now we need to find the distance between a point x1 and x2. These x1 and x2 are points of defined classes. So how to find this distance? When we want to find the distance, how we can find this? Okay. This is equation number 1 for this marginal plane. This is the equation number 2 for that marginal plane. Now if we multiply equation 2 by minus 1, then what we get? W transpose of x plus b equals to plus 1. This is the equation 1 as it is, and what will be, this is as it is. Now what will this will be? W transpose of x is multiplied by minus, okay, this is passing through point of x1, so it will be x1, this will be x2, this is x1, this is x2, this will be minus b, this will be minus of minus, it is minus of minus 1, that is plus 1, which is my third equation, right? So I have these two equations. Now if you add equation 1 and 3, then what you get? W transpose of x1 minus x2, bb will get cancelled and we will get 2, right? Now we have to divide both of the sides by norm of w. Why we want to divide it? Because we want to get the value of x1 minus x2, that is the marginal distance, that is the d which we want to find. So while we are dividing the w transpose by norm of w, the magnitude value vanishes and it behaves as a unit vector, and as a result what we get is x1 minus of x2 is 2 by norm of w. So this is the distance. This is the distance between these 2 points, and I have already mentioned that the hyperplane should be chosen in such a way that it provides the maximum marginal distance between the 2 different data samples of different classes. So this should be maximum, right? Okay, so I am rubbing these things. I hope up to this everything is clear. I have already mentioned that if there are 2 different points like this, we can draw several number of hyperplanes, right? this can be a hyperplane, this can be a hyperplane, this can be a hyperplane, which linearly separates these 2 points. But the hyperplane should be, we have to find an optimal hyperplane for which we can find the maximum marginal distance. I am repeating these things again and again because this is very important. We are in SVM, we are trying to find the hyperplane which separates the 2 different classes with maximum distance between the points, nearest points, right? So maximum distance. Now we know the distance is this, right? So we have to find an optimization function. We have to find an optimization function. What is that? That we have to update the value of w and b, because in y equals to mx plus c, here we are writing it as w transpose of x plus b. So this b and w transpose, we need to update it, right? So if it is this straight line, then w transpose and b will be different. If this is this straight line, then w transpose and b is different. So we have to update the value of the w transpose and b to maximize the distance such that w transpose x plus b is always greater than 1 for positive class and w transpose of x plus b is less than -1 for negative class, right? So I have already explained these things, and this we can write it as this thing. We can write it as or y of I multiplied by w transpose of x plus b greater than equals to 1. Why we can write it like this? Because if y belongs to positive class, say if y belongs to positive class, say plus 1 into w transpose of x plus b is greater than equals to 1, right? And if y is negative class, then -1 into w transpose of x plus b is greater than equals to 1. We can also write it as w transpose of x plus b is less than -1, right? So this can be also written as like this. Okay, and you have to remember this thing. This is very important. You have to remember these things. For any point, we can write it like this. Now, coming to this optimization function, we have mentioned that we have to update this value so that we can maximize this marginal distance. I have already mentioned this is marginal distance, such that what is the condition of this optimization? The condition is that w transpose x plus b be greater than 1 for positive 1 class. We can write yi like this, or this is less than -1 for negative class. We can also mention in this way that such that y of I plus 1 minus 1 w transpose plus 1 w transpose of x plus b greater than equals to 1 w transpose of x plus b less than -1. Okay, so in this optimization function we are seeing that we have to maximize this value, or else we can also write that we can take a reciprocal. Maximization of this value is equivalent to the minimization of the reciprocal of the value, right? This is equal to minimize, take the reciprocal of this norm of w by 2. Okay, now one very important thing you should note here, an interviewer can ask you, not even interviewer, for yourself you should know that why we are taking this minimization, because in gradient descent we need to find the minima value. So When we are training a model, we try to find and reach this minimum value. Okay, so we are coming to this minimum value, so our cost function of the error will be less. I will be explaining this concept of cost function and error later on, but for the time being, know that in gradient descent we tries to converge to the minimum point, and for this convergence going down you are taking the minimum value. So we can write this, we are taking it minimum value, right? So we have to minimize this function. We can write like this, we have to minimize this value. Now in this case I have I have previously mentioned what is hard margin and soft margin is my last video, but just to give you a recap, hard margin is that there will be no misclassified point in between this marginal distance, that is called hard margin. Like green point will never come above this line or blue point will never come below this line, but this is hard margin. In case of soft margin, a green point will lie above this line, and not only one, it can be anything, any number of points, and there will be some misclassified blue points below this line. Okay, so in this case we call it as soft margin. But generally what happens is that in practical scenario, if we try to have a hard margin, it means that the classifier is classifying perfectly. If it is doing that, it goes to overfitting problem. It goes to overfitting problem in case of hard margin. It means that the model has been trained so much that it is going for overfitting. It means that this hyperplane is learned in a way that in case of any text point or blind point which is coming and we want to text this hyperplane how it is working, then it is learned in such a way that it can classify the points in this arrangement properly. But if some another text point comes, then it will not be able to learn. Okay, it will lose its flexibility to learn, and in that case we want to optimize it in a way that like it can learn in a generalized manner, because in real life we want to have a generalized classifier. Okay, so for the purpose of generalization we need some technique that we have to add some term here so that we can avoid overfitting. And this technique is very important, you should know. This is known as regularization technique. When I was in my IIT and I went for campus placement, so at that time there was one company which asked me regulation technique. What is regulation technique? How you are using it SVM? So from my personal experience I am telling you, this is one of the very important questions of interviewer. This is very important. This can comes in interview. Okay, so what is this regulation technique? So we have to minimize this value, and to avoid the overfitting we are adding some terms to it. What is this term? This is C summation of zeta, Ci summation of zeta I, where I runs from 1 to n. Okay, so let me explain you what is C. C is called cost C. This is also called as cost C. This shows how many points can be misclassified, or we can consider it as misclassified to avoid overfitting. Like here in this case, like we are considering 1, 2, 3. There are 3 points which are misclassified and we are considering it, we are keeping it. If we don't keep it, then it will lead to overfitting, and this is not generalized, and we are keeping few points so that it can be generalized. So how many points? Here C is 3. So what is C? C is a number of misclassified data points. right? And what is this gamma? Gamma is the value of the error. Value of error. What is this value? Value is actually distance. And what is I? I runs from 1 to 3 in my case, or it runs from 1 to n. Here, since there are 3 misclassified points, so I is actually the number of the misclassified points. Okay, so for zeta, value of error means the distance from this hyperplane. What is the distance? What is the distance from this hyperplane? Right. Okay. So we are adding this cos c and zeta. This is also known as gamma. Right. So we are adding these two terms to avoid overfitting, and this is called regression technique. So in practical life, what we do in SVM, like what do people do, like we generally use Python, right? So because Python has like lots of open source library, it's it is very easy to use. So what we do in Python, we generally import SVC classifier, that is support vector classification classifier. We generally import it, and without knowing anything what is given as an argument to this function, we don't know that, we just blindly use it. What we do, just in one line you can do the classification. You can have a data, you split it into train and test, and just blindly without knowing anything you can import the SVC module, and you can use just to do the classification for SVM. But you have to know the logic behind it, right? So if you know the logic behind it, then you can tune your model, right? Because this C and gamma, these are hyperparameters, which you can tune the value. It means to find the best classifier or best support vector machine or the best hyperplane, you can tune this value, you can give certain value, and you can do experiment. Here if C is 0 or like any of the like all summation of all the gamma is 0, then this then we can have one hyperplane. And if we change the value of C and change the value of the gamma, then we can have similar hyperplane but with different number of misclassified point, right? So if we change the value of C and gamma, we will be incorporating few of the data points which are wrongly misclassified, and here we will do some kind of hyperparameter tuning to find the best set of C and gamma, which will give you the best hyperplane, that is the best SVM, by which you can classify these 2 points. This covers the concept of the maths behind the SVM.